a half-kilogram metal ball impacts 20-kilogram metal block resting on a horizontal surface. The coefficient of kinetic friction between the block and the surface is 0.2. After the impact, ball rebounds with a speed equal to 0.2 meters per second and produces a displacement of the block 0.5 meters measured from the position of the impact. Andre, what was the speed of the block just before the ball impact? Just after the ball impact, before it was 0. What was the initial speed of the ball? Calculate kinetic energy of the ball and block before and after the impact. What kind of collision took place during the impact? And calculate the impulse of the block from the moment just after the impact to his final position. Impulse. Okay, it is what it is. So first of all, what was the speed of the block just after the ball impact? What we know for sure, that momentum is conserved. That is always the question. That is never wrong. Momentum is always conserved, but kinetic energy is not always conserved. Sometimes it transforms into something else. Energy is always conserved, but kinetic energy, in other way, mechanical energy can be transformed in other kinds, heat, friction, heat, in sound, and whatnot. But momentum is always conserved. So from the momentum conservation, we have 0.5 kilogram balls going in that direction and rebounds with 0.2 meters per second, and we have 20 kilogram blocks that moves for the half meters. So block decelerates from the start to the for this 0.5 meters, and all that this deceleration, that is because of frictional force. So mass times the acceleration of one thing, that is the second Newton law, is equal to the force, and that force is mg, dynamic coefficient of friction. And from here, that deceleration is equal g times mk. That is from one thing. From other thing, this is for the when the acceleration is negative. At the end, speed will be 0. At the start, we don't know. That is what we need to find out. And this is the 0 at the end. This is the acceleration that we calculate from here. And this is half a meter. So when we combine these two equations, we get that the start speed of the block was 1.4 meters per second. And that was the answer, Andre. What is the speed of the block just after the ball impact? Okay. Then second question is, what was the initial speed of the ball? So we don't know what was the initial speed of the ball. We know that it rebounds back and that it had 0.5 kilograms. So momentum prior to impact has to be equal to the momentum after the impact. So you could do that from here, you could do that yourself, or for complete written answer, please follow link in the description. If you want more of this, please subscribe and tell your friends. So there is a lot to work from here, but after the 8, it's a little bit easier. B, C, and D, and E. Okay. Nothing. See you. Bye.